Here is your script * trimmed and refined to fit approximately 6 minutes narration, about 750 to 900 words, while keeping the cinematic tone. A million miles from Earth, far beyond the glow and warmth of our planet, a silent observatory unfolds in darkness. Suspended near the Sun-Earth L2 point, the James Webb Space Telescope operates in a realm colder than almost anywhere naturally found on Earth. Protected by a giant sunshield the size of a tennis court and floating in near-perfect stillness, it waits patiently for the faintest signals in the universe. Its mission is not simply to look far away. Its mission is to look far back. Every beam of light captured by its mirrors has traveled for billions of years before reaching the telescope. Some photons began their journey long before Earth existed, before the Sun was born, before life emerged. To observe them is to witness history written in light. During one of its deepest observations, Webb focused on a distant galaxy from the dawn of cosmic time. Its light comes from less than 300 million years after the Big Bang, when the universe was still young and only beginning to assemble its first structures. Scientists expected to find a primitive galaxy, small, simple, barely forming. What they found instead was astonishing. The galaxy appeared surprisingly mature. Inside its compact structure, enormous clusters of young stars were already blazing with intense energy. Hundreds of millions of suns may have ignited almost at once, flooding surrounding darkness with light. But the greatest surprise was hidden in the colors of that ancient glow. When astronomers analyzed its spectrum, they detected oxygen. That discovery carried enormous implications. In the earliest universe, only hydrogen and helium dominated. Heavier elements like oxygen are forged inside stars and released into space when those stars die in supernova explosions. For oxygen to exist in such an early galaxy, multiple generations of stars must already have lived and died. The universe, it seemed, may have evolved far faster than expected. Instead of slowly building complexity over billions of years, some galaxies may have accelerated almost immediately after the first stars appeared. Massive stars formed quickly, burned fiercely, and died violently, enriching space with heavier elements that seeded new stars again and again. In that distant galaxy, astronomers may be witnessing one of the first great chemical factories of the cosmos, a place where the ingredients for planets, atmospheres, and perhaps even life were already being created while the universe was still in its infancy. And that changes how we think about cosmic beginnings. Because if chemical complexity emerged so early, perhaps the ingredients for habitable worlds arose much sooner than anyone imagined. Perhaps the road to life began earlier, much earlier. Webb also uncovered another mystery. Some early galaxies may host rapidly growing black holes only a few 100 million years after the Big Bang. That challenges long-held assumptions. How did such massive structures form so early? How did black holes grow so fast? Were early cosmic conditions more extreme than models suggest? Each answer leads to deeper questions. And a larger picture begins to emerge. The early universe was not simple. It was active, evolving, and unexpectedly complex. The cosmos has never been quiet. After revealing the distant past, Webb turned closer to home and found mystery again. It observed a faint wandering object drifting through space, a brown dwarf. These objects exist between stars and planets, too massive to be planets, yet too small to ignite the sustained fusion that powers stars. Inside its thick atmosphere, scientists detected methane, water vapor, and complex molecules swirling through dense clouds. Subtle brightness changes suggested powerful storms sweeping across its surface. Winds may roar at astonishing speeds. Clouds of exotic minerals may drift through dark, turbulent skies. Then something even stranger appeared. Faint glowing patterns high in its atmosphere, displays resembling auroras. Some researchers suggest an unseen moon may be interacting with the dwarf's magnetic field, generating these emissions. An invisible world revealed only through its influence. Worlds around worlds. Mysteries inside mysteries. Webb then turned toward distant planetary systems, and what it found was not calm architecture but chaos. In one system, astronomers discovered a giant exoplanet moving along a wildly stretched orbit shaped by immense gravitational disruption. Its strange path hints at a violent past, perhaps a close encounter with another giant planet, a distant companion star, or even a passing interstellar object. Planetary systems are not always stable. Many begin in chaos. Many survive through upheaval. Some do not survive at all. In another region, Webb observed a giant gas world spiraling slowly toward its parent star, a doomed planet. With every orbit, gravity pulls it closer, heating its atmosphere and tearing it apart. Over time, its outer layers may escape into space, forming glowing streams of gas feeding the star itself. Eventually, the planet may be consumed by the very sun it circles. Scenes like this reveal an unsettling truth: planets are not permanent. Some are ejected into darkness as rogue worlds. Some collide in catastrophic impacts. Some are slowly destroyed.